Hello everyone, this is XM Physics. In this video, we'll figure out the formula for the potential of a point charge. So consider two positive point charges, Q and Q, separated by a distance r. One view is that there is an EPE of kQq over r stored between the two charges. The other view is that the big Q produces an electric potential V around it, which results in a small q having an EPE of q times v. So what should v be? So the first view says that the EPE is kqq over r. And the second view says that the EPE is qv. So what is v? That's right. The electric potential produced by a point charge q is described by the formula kq over r. If we think of the electric potential as the height or elevation of an electric landscape, then from the formula we can tell that a point charge will produce a positive potential that becomes more positive nearer the charge. So it's like a positive point charge raises the ground around it to produce a mountain around it. On the other hand, a negative point charge produces negative potential, and the potential becomes more negative as you get nearer to the charge. So it's like a negative point charge depresses the ground around it to produce a crater around it. A positive test charge approaching a positive source charge would be gaining EPE. It's like climbing up the slope towards the electric mountain peak. A positive test charge approaching a negative source charge will be losing EPE. You can imagine it's like falling down along the slope towards the center of the crater. Now remember that the world is upside down for negative charges. So a negative test charge will see a positive source charge as a crater instead of a mountain, and it will lose EPE as it approaches it. A negative test charge would see a negative source charge not as a crater but as a mountain, and it will gain EPE as it approaches it. Alright, this is XM Physics. I try to make studying physics fun. If you enjoyed this video, please like, share and subscribe. That's all. Ta-ta!